So unfortunately my camera ran out of battery for that last one and we're almost done, so I'm just using my cell phone. The other main way that we were going to do this problem, see here's the same problem set up. Need a selfie stick or something. There's that information. Was to break it up into, let's try it this way, two separate x direction and y direction pieces. So you can see now I've broken down my initial velocity vector into x component, which was the 20 that was given horizontally, and the y component, which is 0. If the ball was thrown horizontally, it has no vertical component to it. Likewise, gravity is pulling straight down in the y-axis, so there's no x component of gravity's acceleration. Now the time shows up in both steps because time is a scalar. It doesn't get broken into components. And then one of the questions was, what was the y displacement? What was the x displacement? The other was, what is the y displacement? So I can figure out one of those from this set of information and the other from this set of information. Looking in the x first, now this is the same equation I used when I had it all jammed together, the x and the y at the same time. It's just now I'm looking at only the x components. So I have 20 times 4, not 20.4, plus 0 for my x component of the acceleration, which makes the entire second term 0. And I get a delta x of 80 meters, which was exactly the I hat component of the delta r vector I found earlier. Likewise, when I go in the y direction, I use all the y components. My initial y velocity component was 0. Then I have, you can see, the y components for the acceleration plus the 1/2 and the t squared. I finally did the math. It turns out that's actually equal to negative 78.4. So, like I said, a little less than 80. I was close. So there's the delta y. And, and it's negative because the ball was displacing down from the top of the cliff to the bottom. And so this is another way of finding the exact same two pieces of information that I would have found if I put it all together with the IJK notation. It works either way. You can do whichever one is most comfortable to you. Sometimes one is easier than the other. It's really just a matter of preference. So that will conclude our online tutorials, and I will see you on Monday.